Hey guys, it's Dr. J, and I'm back in the classroom with the mask, okay? But it's still me. There's a mask, I'm still the same guy. All right, so today we're going to do a chapter 1 review, okay? So we're gonna go back through a bunch of the concepts that we've read about and studied and seen in our lecture in chapter 1, and we're going to do some review that will help us complete the review problems at the end of the chapter. So let's see what we're doing with this. So our goal will be to complete these review problems, okay? So today what you're gonna submit are gonna be notes and answers for the problems that I asked you to do here, okay? So let's get started and I'll tell you which problems to do as we go along. The way this is gonna work is I'll give you a quick whiteboard lecture on concepts that are related to at least one of the problems here, and then I'll go tell you to do that particular problem. Then you'll come back after having completed that problem and you'll receive additional instruction that will help you do other problems. In total, we're gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We're gonna do 17 out of these 21 problems, okay? So this is a solid lesson here. All right, let's get started. So let me bust out my whiteboard. Oh, here we go. Okay, so whiteboard, here we go. All right, so first order of business, okay? The concept of a reference point. And let me go ahead and get back to my blue writing. So reference point. Okay, so a reference point, you've learned about this before, right? But we really need to stress what's going on here with reference points and why we use them. So reference points, right? A reference point is a fixed point. Okay, a fixed point. From which distances can be measured, or distance can be measured. Okay, so an example, right, would be like this. So the water fountain is 10 feet from the swing set. Okay, the swing set in this case would be our reference point. Okay, because the distance that the water fountain is from the swing set is being measured. So that's our reference point. The water fountain is 10 feet from the swing set, which is our reference point. Okay, so the key thing about a reference point is that it's fixed, and we use the reference point, okay, to establish the distances of other things which may or may not be moving. Okay, so right now I want you to go ahead and get these notes in your notebook, and I want you to try chapter review question. Okay, this is on page 38. So page 38, number 1. Okay, go ahead and try number 1, and then come on back when you're finished. All right, so I'm going to go ahead and clear this all away, and we're going to take a look at some more concepts. So one of the things that we need to be able to do is to determine average speed. So determine, average speed. So I'll say determining. Determining average speed from distance versus time graphs. Okay, So determining average speed from distance versus time graphs. All right. So how would we do that sort of thing? Let me fix up that E. My E's tend to look like O's. Okay, so how would we do that, right? So let's take a look at a graph. Okay, so here's distance. Okay, in meters. And here's time in seconds, okay? And we're gonna go all the way out here to 10 seconds. All right, and we're gonna go up here to the top to 100 meters. And we actually, yeah, 100 meters there, and we're gonna have 50 meters here. Okay, 50 meters there. So we're gonna take a look at two curves, all right? So somebody gets started and he kind of goes slowly, then he goes fast, right? And he runs and runs and runs, and then he starts to slow down and he ends here, okay? And so what's his average speed going to be, right? So remember, average speed is just equal to total distance divided by time. Okay, so in this case, his average speed is 100 meters divided by 10 seconds, which equals 10 meters per second. Okay, that's his average speed. Okay, let me do a better job writing this over here. So total distance, so total distance. Okay, that looks like a dist. Okay, so 10 meters per second. Well, what about a second person, right? So the second guy takes off right away, but then he slows down immediately, right? And he conks out at 50 meters. Okay, so he's done at 50 meters. So his average speed, right, is going to be 50 meters divided by 10 seconds, which equals 5 meters per second. Okay, so he didn't go as far in the same amount of time. This guy only went 50 meters as opposed to the first guy going 100 meters. So in the same amount of time, 10 seconds, so he had a slower average velocity. Okay, so what I want you to try right now is number 3 on page 38. So page 38, number 3, okay, chapter review problem. Go ahead and give it a shot and come on back when you're finished. All right. So let's go ahead and take a look at another problem or a concept related to another problem. Okay, so what we're going to look at now is the concept of displacement, okay? The concept of displacement. And so we're going to look together at what displacement is, okay? So displacement, and I'm sure you already have this in your notes, but let's review. So displacement, right? Displacement I want you to think about this as distance, and in parentheses, I'll put traveled, from a fixed, okay, or reference point. Okay, so that's displacement, right? So let's take a look at a couple different options, right? So here's our reference point, okay, right here. That's our reference point. Okay, and we have two different objects, okay? So we got this purple object, right? And the purple object starts at the reference point and goes all the way over here, then out here, then over here, then in this way and that way, right? And winds up right there, okay? Then we have our green object. And our green object starts here, of course, at the reference point and ends over here. Okay. Which object has a greater displacement? The purple object or the green object? Well, let's look at our definition. Distance from a fixed point. So the green guy actually has greater displacement because it ends up farther away from the reference point, okay? Greater displacement, which you can think of as greater distance from the reference point, okay? Displacement slash distance from the reference point. All right, and so what I want you to do now is take a look at page 38, number 4. Okay, number 4. And what I'm gonna go ahead and do here is I'm gonna go ahead and stop this video. So this gets us ready for problems 1, 3, and 4, and we'll have additional videos uploaded to get us ready for the additional problems in our chapter review. I'm gonna have to do this one in pieces, okay? All right, guys, so good luck and stay tuned.